Yes, this is worksheet 6 for assignment 6. So we're going to work on worksheet 7. Worksheet 6 is based on inequalities, and here you have an introduction on the term or the concept of inequality, a comparison, and there's the inequality sign, which has a less than part and a greater than part. Okay, the opening is called greater than, the point is called less than. So we can take a copy of this right here. Paste it here. Okay, so we're talking about worksheet 7, and worksheet 6 starts on the 1st. So worksheet 7 is 1 week after the 1st of March. Well, we're talking about the 8th of March for worksheet 7. Yes, and worksheet 7 now is based on module 7. Module 7 is based on coordinates, midpoint of line. Here you have a graph already and a line, and the midpoint of the line. The line shows you the behavior of the y variable. The x always increasing from left to right, and here's a graph already pre-established already, and you can find the midpoint of the line. Okay, so here you have examples and you have exercises. You can also find the length of a line. Here you have a line on a graph. The line shows you the behavior of the y. X increases from left to right always. Okay, and you can find the length of the line, but there the line is given already. Okay, remember that. Here you have examples and you have exercises. You can find the gradient of a slope. Gradient is rise over run. Gradient, the symbol for gradient is m. Why not g? G is used for gravity. M stands for, I guess, for mount or moute in French. Climb, C could not be used because C is for the y-intercept. Okay, so they probably have to use the M for mount. And here the line is given. This shows you that the y variable is increasing and the x always increases from left to right. So you can get the gradient of the line, okay? And the line is given here already. Okay, so you have examples and you have exercises. Now you have the straight line graphs, okay? The equation, y is equal to mx plus c, m for gradient, c for y-intercept, okay? C for constant and m for mount, the slope, all right? So therefore now, the y here shows you that the y variable is increasing. That's what the line here is showing you. X always increasing from left to right, and this graph is depicting an example of a straight line graph. But the graph, to get the graph, you need points, okay? And here you have a table with points. Points can be plotted, and then the line can be obtained. And then the equation here now, y is equal to 2x plus 3. So the y could be a potential variable, and the x could be another potential variable. Anytime you see x and y in a maths class, it represents a potential variable in the real world, okay? And to obtain the graph now, values have to be obtained from, have to be collected from a survey and then plotted, and then a line can be obtained. But here, this will not be done. The equation will be given already, or you'll be required to obtain the equation and the points will be given, okay? But they have their origin from describing a real system, okay? They call that mathematical modeling, okay? In worksheet 7, it's a mathematical modeling will be discussed, taken from this Wikipedia extract from the internet. Here it is. It's not my definition. It was taken from the internet. It says a mathematical model is a description of a system using mathematical concepts and language. So you have what you call mathematical language. Math can be considered a language, and a model is used to describe a system, okay? For example, a researcher wants to describe the relationship between study hours and math score. That's a real event. So he can survey 42 students and obtain the following values, okay? Here, a student said that they study for 180 minutes and they score 60. One said they study for 60, they got 90. One said 120 and they got 70. So these values were obtained And from this now, an equation can be obtained, all right, by going into insert, that's Excel, scatter plot. Click on scatter, you get a scatter plot. Go to quick layout and go to functions, and then you get a line, all right? The same line that we're talking about, a straight line. Look the gradient and look the y-intercept. This line shows you the behavior of the math score, okay? Just to make this line more visible, here it is, it's in dotted. But you can appreciate the fact that it was obtained using real values from a survey, okay? So from survey to a line on a graph, okay? And as you can see, according to this line, the score decreases because this line shows you the behavior of the score, the y variable, as the time increases. Why is this so? Why is this? This is what the data is showing. This is left for further research, but the whole point is that real values were obtained by conducting a survey, okay? Here it is, and a graph was obtained to describe the relationship between those two variables, hours of study and score, by simply putting the values in Excel, okay? And here you have it. So with this line, the further analysis can be done with this line. Y is equal to mx plus c minus 0.0161 and 74.44. Here it is, minus 0.161 and 74.44. S would be the dependent variable, S for score, and H for hours, X for hours, Y for score. Anytime you see X and Y, it means a potential variable in the real. Okay, always bear that in mind. Okay, anytime you see X and Y in a maths class, the Y is a potential variable. Here it is. Here Y is for score. Okay, and hours of study, X for hours of study. All right, and here we're going to formulate the questions from the module. We're going to start from the beginning, starting with the first set of questions in this module to formulate worksheet 7. Okay, so the first set of questions is on midpoint. And here we're going to start creating our worksheet 7. Okay, question 1.